Okay, so this video is going to be dealing with the second activity from last week's lab. Again, we're going to start off by looking at what the question is actually asking us, as well as that looking at the diagram that's been provided. For the last question, it was actually semi-structured in the way that this section was drawn out for you. This time you're given dimensions, so then you have to redraw the information that you've been given here, which is actually quite simple. There's no tricks or anything inside here that will mislead you to actually draw what's being presented. Given the directrix, so our line DD here, axis, as you can see the red one here, axis, as well as an eccentricity of 0.75. Okay, I know from that straight away it's an ellipse, because remember your eccentricity, if it's 1, it's a parabola. If it's over 1, it's going to be a hyperbola. If it's less than 1, it's going to be an ellipse. This is less than 1, so we're nowhere for a fact we're dealing with an ellipse in this question, elliptical curve. Very important to be able to recognize that. And point P on the curve. So we have point P, which I've drawn out here, which is above here, which is going to be a point on the curve itself. Determine the position of the focus and draw a portion of the curve. Construct a tangent to the curve from point A. Okay, point A is going to be here, so that's going to be A here. Okay, so I've just drawn out the information that we've been given. Now from this, what I can do first of all is draw my eccentricity line. Now I know my eccentricity is going to be 0.75, which I change here to fraction form, which is going to be 3/4, same thing as 0.75. And I know that to draw my line, all I have to do is come out 4 and go up 3. So come out 4 from my directrix here and come up 3. And what I can find then is a point at which is on my eccentricity line, knowing that it is of 0.75. Now this can be used no matter what. If you have your hyperbola, remember we always draw an eccentricity line of 45. Thing about 45 is it's the same, 1 is the same as 1 over 1. So if you went over, let's say 10 here, went up 10, that's where you'd find your 45. For when you're dealing with less than 1, you have to deal with the fraction here. So I'm going to go for 4 across, like so. And then we're going to be going 3 up. Like so. Now I'm going to extend a line from where the directrix here passes through the axis, through that point, and call that my ECC line, short for eccentricity. Now that I have my eccentricity, all I need to do is find my vertex and my focus, which will help me construct the curve. To do that, I actually have information here that will help me, and that information is actually this point P. So if I use my eccentricity here, if I use this formula that we've been given, with the information we've been given, I can actually find out how the distance from the directrix to this point, perpendicularly, so that distance there to here, how that is related from the point on the curve back to the focal point. So if we see here, our eccentricity is equal to the distance from the focus to a point over the point to the directrix. So I know if I actually take into consideration my eccentricity of 0.75, and I know that my distance from, let's say this point A to P, so from the directrix to the point in the curve, is going to be 60. I know that this is 0.75, so that's basically 3/4 of 60 is going to give me 45. So if I get 45 here, 45 millimeters on my compass, which is going to be my 3/4 of this distance here, and I scribe an arc. Just ensuring that that's perfectly 45, close enough. Where I scribe an arc and it hits through my axis, that is going to be where my focal point is. So this point right here is going to be my focal point. I can put that in as F. Now when I have my focal point, which is here, I know if I travel back at 45 degrees, where it intersects, I will find a point at which I can drop perpendicularly to the axis to find my focus, or my vertex. So I go back here, 45 degrees, drop him down. Now here I have my vertex. Now the great thing when you're dealing with an ellipse, as long as it's small enough to actually follow out this construction page, if I go up at 45 degrees from the focus in the other direction, where that eventually makes contact with the eccentricity line, you see how it's slowly becoming closer. When that finally intersects, so they'll probably meet up here somewhere, and I drop that straight down, then I have my focal point on the opposite side of my ellipse. For this, I'm not too bothered because I've been asked just to draw a portion, construct a tangent. Yeah, so draw a portion of the curve. So all I have to do is draw a section of the curve to show that I can find it. I don't have to draw the whole thing, so I'm not too worried about finding my second focal point and vertex over here. So now that I have this information, I can use my eccentricity method to complete the drawing. Again, I draw a line perpendicular to the axis through the focal point, which is going to be my focal line. As well as that, I can start constructing my lines as well, which will help me complete the actual eccentricity method. Okay, just put a few of them in there. Now, the more you put in, they don't have to be any particular distance up along here. You can just do it randomly, but the more you have to actually deal with, well, the more points you have to actually draw that curve. Now I'm actually going to use the one here that's on P as well. Set this up. Now if this is correct, it should come back and hit on P. A small bit of inaccuracy might get it set to veer a small bit off when you scribe it down. Go a small bit further as well, just in case I need to extend it for the tangent I need to do for the second part of this question. Again, get your compass from the focal point, extend out any one of the points you've now located, swing your arc where they intersect. It's a point in the curve. This one should come in contact where P is, just about. If it's a small bit off, it's just a small bit of inaccuracy somewhere. It's also going to make contact where the focal line hits the ECC line. Now I have a few different points so I can draw my curve. I have my vertex, which is going to be on at this point here. At this point, where my focal line intersects my ECC line. I have point P. I have this point here and this point here. You can see the curve is actually starting to come back down as you would for an ellipse. Now, depending on how well you are at freehand drawing, the better your curve is going to be. Try your best. I wouldn't sketch it. Try to keep it one consistent line. Sketching is a bit of a problem because if you sketch it and it's kind of keep scribing lines like that, it's not clear where the actual one line which is supposed to be represented is. Like so. Hopefully your curve is much better than my one. As well as that, now I can use my point A here to construct my tangent, which is that. So construct a tangent to the curve from point A. What I would do there, I get your book, I'd open up the section that's talking about ellipses in the conic section, then I go to the place that's talking about tangents to an ellipse. So tangents to an ellipse from a point on the curve, that's the one we're going to need. So you can see there we have a point on the curve like we do here. We have our focal point, which we do here, and it also tells us it's 90 degrees between that line and the line up to the point where we can draw from here up to an extent for a tangent. So very easy. Just like it's done in the book, I join that point back to my focal point. So point A, back to F, like so. 90 degrees from that. So extend this out a bit further so I can actually ensure that my line is going to be 90 degrees. Great thing about these set squares, you can use the inside of them. Extend that up. Now as you can see here, I actually need to extend my arc a bit further so it actually intersects with it. So I'm going to do a second point over here. So extend this on, and now I have where it intersects here. That's going to be the point which I can join back to A and extend from my tangent. Like so. And that is your question then completed. Now again, ensure that anything is annotated. If there's particular constructions here you want to highlight, use different colors and things like that to identify them. For example, your ECC line, you can put that green or something and put ECC in green. Your focal line in red, put focal line in red. If there's particular construction like this one, you can use arrows stating that, you know, this goes up, hits the ECC, arrow going across that is parallel with the axis, and then an arrow on the curve here saying that's curving down and where it intersects is a point in the curve. All them kind of things. It's important to annotate here. The reason I don't do it, again, using the video, that's how I'm explaining my point. As well as that, if you want to see any particular construction, all you have to do is move back the video to see any particular part being constructed. But if you're doing this one time only, if you're doing it on a projector or through a visualizer, using them colors can then make it easier for the students to go back and see what's happening. And even for yourself, for studying for exam, you might forget any particular thing that was covered here. Having them color coordinations, identifying the different parts can help you then recall that information.